Okay, hello everyone. Welcome to Geophysics Academy. Okay, so we already know Geophysics Academy UPSC कंबाइंड जियो साइंटिस्ट एग्ज़ाम का जो एग्ज़ाम है उससे रिलेटेड एक्चुअली कुछ क्लास वगैरह पिछले जो इतना वीडियोस था उसमें लिया था। ठीक है, तो आज से Geophysics Academy अगेन स्टार्ट करने जाने वाला है। जो स्टूडेंट 2026 में यूपीएससी कंबाइंड जियो साइंटिस्ट एग्ज़ाम का देने वाले उस लोगों के लिए, और अगेन जो स्टूडेंट 2025 में मेंस का एग्ज़ाम देने वाले हैं उस लोगों का मेंस का जो जियोफिजिक्स रिलेटेड जो सब्जेक्ट है, ठीक है, उसका डिटेल्स एक्सप्लेनेशंस करने के लिए हम लोग फिर से हम लोग स्टार्ट करेंगे वन बाय वन। एक एक टॉपिक को हम लोग डिटेल्स वन बाय वन डिस्कस करने वाले हैं, क्योंकि बहुत स्टूडेंट का रिक्वेस्ट था चैनल में यूपीएससी कंबाइंड जियो साइंटिस्ट एग्ज़ाम का कुछ वीडियो देना है और कुछ जो टॉपिक्स है उसको अच्छे से समझना है। इसलिए मैंने सोचा इतना सारा वीडियोस लगभग मैंने 20 से लेके 25 वीडियोस डाला था। उसमें बहुत सारा स्टूडेंट लोगों का कमेंट आया है, उसको मैंने इंस्पायर किया एक्चुअली मुझे। हाँ, मेरा वीडियो स्टूडेंट लोगों के पास बहुत इंपॉर्टेंट हो रहा है, बहुत यूज़फुल हो रहा है, इसलिए मैंने सोचा फिर से इस सीरीज को स्टार्ट करा जाए एक्चुअली। ओके, सो वी अगेन स्टार्ट द यूपीएससी कंबाइंड जियो साइंटिस्ट एग्जाम प्रिपरेशन सीरीज. So this is our lecture number 1. Okay, so first of all, in lecture number 1 we deal what first chapter we deals mains paper 1, mains paper 1. Okay, this mains paper 1 consists of two papers actually. One is geophysics, this is part A, and physics, that is basically part B. Okay, but already know physics, in physics sections also I will cover, and geophysics sections also I will cover. Okay, so in geophysics part there are a lot of important in geophysics part there have a syllabus, right? Solid earth geophysics, और है earthquake seismology, mathematical methods in geophysics, method in geophysics, और geophysical inversion. Geophysical inversions, that is for geophysics part. Okay, and for physics part there is a syllabus, that is for part A syllabus, part A. And for physics part there are mathematical methods, electrodynamics, और जो है इलेक्ट्रोमैग्नेटिक थ्योरी. And introductory atmospheric and space physics. Introduction of atmospheric and space physics. Okay, so this sections is for part B. So and every so in solid earth geophysics, okay, so for part A for geophysics and part B for physics. So I'll try to cover for mains paper 1 detailed syllabus in our channels, then we go for part paper 2. First of all, we cover paper 1 physics and geophysics. So it's a very long syllabus. Okay, it's a very long syllabus. So in this syllabus I mainly cover the geophysics part. Okay, mainly cover the geophysics part and also some physics parts also. Okay, so I will try my best to give you the proper explanations of each and every topics. So it's a lengthy, so I need 1 year, full 1 year to complete the whole paper 1, paper 2, paper 3 syllabus. Okay, so in today's class I start with solid earth geophysics. In today's class I start with solid earth geophysics. In today's class I start with solid earth geophysics. So in solid earth geophysics, there are some important topics. So first of all I mention you the important topics, and then I discuss each and every important topics in proper way. So there are important topics are elastic waves, okay, and internal structure of earth, internal structure of earth. Second topic is Adam-Williamson equations. Adam-Williamson equations. So elastic wave and internal structure of earth and Adam-Williamson's equations. Okay, so for these two topics are very important for solid earth geophysics. We cover इन डिटेल्स. ओके, तो जो दो टॉपिक्स है, इस दो टॉपिक्स को हम लोग अच्छे से यहाँ पे डिस्कस करने वाले हैं. 1 बाय 1 एक एक टॉपिक को हम लोग डिस्कस करेंगे. फर्स्ट टुडे हम लोग इलास्टिक वेव को लेके डिस्कस करेंगे आज. देन एडम विलियम इक्वेशंस. ओके, दिस टू टॉपिक्स आर वेरी वेरी इंपॉर्टेंट. So let's start our video with elastic wave theory. Elastic waves mean we are discussing at the seismic wave. Topics is here seismic wave. Okay, seismic waves. So as we know, seismic waves in a medium, okay, in a heterogeneous medium, in a medium, actually consider a medium, and in a medium the seismic waves is actually arise due to earthquake, we already know. But here we discuss the full physics of these seismic waves, how these seismic waves are actually propagated through mediums. It is complex process or it is simple process we describe. And first of all, what are the assumptions? Based on that assumption, this seismic wave propagating through mediums. And also, when a seismic wave propagated through mediums, then the particles of the medium is executed what type of motions, and also and particles are displaced or not, right? Or is particles displaced, then the medium then the medium's energy is transformed from one point to another point by in which way. So there are a lot of questions, right? When is seismic wave propagating through mediums, there are a lot of questions actually arise, right? So what are the questions? How seismic wave propagate? What is the assumptions actually? It's seismic wave propagations, and if seismic wave propagations is particles are displaced or not. If particle is displaced, how energy of this medium is transport from one point to another point. These are the points. These are the points is actually described here in details. So first assumption of propagations of seismic wave. So okay, seismic wave actually seismic wave arise due to earthquake. Okay, in details we earthquake seismology in the next chapter we details, don't worry. This is the important point. The seismic waves arise due to earthquake. So the seismic waves, what are the assumption for seismic wave propagations? What are the assumptions for seismic wave propagations? Okay, assumption for seismic wave propagations. The assumption is the propagations of seismic wave or seismic disturbance. Okay, the propagations of seismic wave or seismic disturbance is that it travels by elastic displacement in the medium. Okay, elastic displacement. Okay, it's okay. Very important point. The propagation of seismic wave or seismic disturbance is traveled by elastic displacement in the medium. Elastic displacement in the medium. So basically, so this is the primary assumption, right? This is the primary assumption. So elastic wave, seismic waves arise or emitted or generated from a source, and then when this wave is propagating through a medium, then the medium have some elastic displacement. That is important point. This medium have a elastic displacement. Okay, so basically this elastic displacement के बारे में हम लोग वन बाय वन एक एक पॉइंट को हम लोग यहाँ पे एक्सपोज करने वाले, राइट? सो व्हेन ट्रैवल इलास्टिक डिस्प्लेसमेंट, मीडियम का इलास्टिक डिस्प्लेसमेंट हो रहा है, इसका एक्चुअल मतलब मीनिंग क्या है एक्चुअली? So basically means when seismic wave has traveled some distance इसको हम लोग पिक्चरली समझेंगे. एक्चुअली हम लोग मेंस के लिए पढ़ाई कर रहे हैं, इसलिए थोड़ा बहुत थ्योरी भी लिखना ज़रूरी है. ऐसे जस्ट हम लोग मैथमेटिकल फॉर्म को एक्सप्लेन करके चले जाएंगे तो दिक्कत होगा, तो इसमें हमको डिटेल्स नोट्स के फॉर्म में आपको मिलना चाहिए, ठीक है। हैज़ ट्रेवल्स फ्रॉम सम डिस्टेंस, राइट, ट्रेवल्स फ्रॉम सम डिस्टेंस अवे फ्रॉम इट्स सोर्स, away from its source, its amplitude decreases. Okay, its amplitude decreases and the medium deform elastically, right? Amplitude decreases and the medium is actually deform, and the medium deform elastically. ओके, सो मीडियम इलास्टिकली डिफॉर्म हो रहा है और सिस्मिक वेव का एम्पलीट्यूड क्या हो रहा है, डिक्रीज हो रहा है. व्हेन द सिस्मिक वेव passes traveling some distance from the source. Okay, it means what the medium deform elastically. It means the particles of the medium, the particles of the medium carry out simple harmonic motions. Why? Because deformation is elastic. Because deformation is elastic. Due to this elastic deformations, the particles of the mediums carry out some simple harmonic motions. Okay, carry out simple harmonic motions. Okay, that is important. So as particle motions is simple harmonic, then how the seismic energy actually transmitted? So that is very complex, right. So as the particle of the medium due to seismic wave have a motions like simple harmonic motions, it means energy must be transmitted. What is the energy? Seismic energy. Seismic energy must be transmitted to the medium. So when a seismic wave passes through a medium, then medium is elastically deformed, and due to this elastically deformations, particle executed simple harmonic motions, and then seismic energy will be transmitted, right? This is the actual process motions. Hence the seismic energy is transmitted transmitted. So these are the main assumption. Based on these assumptions of seismic wave propagations, we carry out the next theories actually. So here seismic energy is actually transmitted, right? Seismic energy. Now there is a very important point. This seismic energy or seismic wave passes through a medium means seismic energy. So we have a point, seismic wave propagations. It means seismic energy transmissions. Actually seismic energy transmissions, transportation, not transmission, transportations. Okay, this is the important point, seismic energy transportations. Okay, this is a basic idea, seismic wave. Now the classifications of seismic wave. Okay, now the classifications of seismic wave. Seismic wave are classified in two ways. One is body wave, other is surface wave. So, what is body wave actually? What is body wave? What is the meaning of body wave? It means the seismic energy or seismic wave when transport in a medium okay, this part of the energy, this seismic energy is actually propagated in two way, right? So let us consider one point, the source of this seismic energy or seismic wave, and this seismic energy have a transportation actually in a medium. So this transportation is actually occurs in two way. One is energy propagated through the body of the medium. Another is seismic energy spread out over the surface of the surface. So actually there are two cases. Seismic energy when earthquake occurs, then seismic wave actually generated. So it means seismic energy will be generated, and this seismic energy, few parts of this energy, seismic energy, is propagated through the medium, another is spread on the surface. So based on these two principles, seismic waves are is actually classified. One is body waves, another is surface wave. So for body wave, seismic energy propagates through the body of the medium and surface wave the remaining part of the seismic energy spreads out over the surface. Okay, so first one case energy propagate, another case energy spread out over the surface, right? So there are two cases actually. If we understood in pictorially, okay, let us consider here a point P is the source of seismic energy, okay, and then this seismic energy is spread over the surface. Just surface over the surface. This wave is spread over the surface, right? Along this. This is surface wave. Another case is this energy will be propagated to the body so this is called wavefront. So this is called surface wave, this is called body wave. So it means body waves, it means propagations of seismic wave. It means when seismic energy propagates through a body, actually propagates through a body, it's propagate like wavefront. Energy actually propagate like a wavefronts through a body. Okay, like wavefront. So okay, so this is the case actually. Surface wave, it's a spread over the surface, and for body wave, seismic energy propagated one point to another point like wavefront motions. Like, so for body waves, body waves are propagating. Body wave propagations mean, actually here I will take a points. Body waves propagations means displacement of wavefront. Okay, displacement of wavefront. That is very important point. Please remember, when you deal with mathematics, then that it is useful. So seismic waves, energy propagated through the body, remaining part of the seismic energy spread out over the surface, and we deal with body waves propagations mean displacement of wavefront actually. Okay, now we go to calculate the body wave. Okay, next we go in details seismic body waves. So next we go to in detail seismic body waves. What is seismic body waves, etc. Seismic body waves. You know, when this seismic body waves, okay, travel a distance r from its source in a homogeneous mediums, actually the wavefront has a spherical shape, है ना? When a body waves travel through a mediums, then the wavefront is like a spherical shape at particular distance. right? Displacement of wavefront. So when this body wave travel more and more and more in distance, then the shape of this wavefront will be changed, right? Will be changed. So then spherical wavefront will be changed to plane wave, like plane wave. So body wave, in body waves, it's actually occurs displacement of wavefronts. So this, the shape of this wavefront at a nearest point of the source, it's spherical, and when this wavefront moves far away from the source, then this shape of this wavefront is like a plane wave. Okay, so for seismic body waves, there will be two important points. Uh, Two important point when a body waves reaches a distance from its source in a homogeneous medium, the wavefront has a spherical shape. It means the body wave it means the body waves is called spherical wave. Okay, second point is as the distance from the source increases, okay, the curvature of the spherical wavefront decreases. Okay, decreases. So at a great distance, great distance from the source, the wavefront is so flat. It's so flat. Okay, so at a nearest point it is spherical shape, at a far distance it is flat shape. So then the body wave consider as a plane wave, okay. As a plane waves, okay. So seismic body waves are called spherical waves and also called plane wave. That's 2 points are very important. Seismic body waves are called spherical waves and also called plane wave. Okay, now we go to find out the velocity of seismic waves. Okay, next point we'll deal with calculations of here we take a before these calculations here I take a notes. Okay, you put these calculations here you take a notes, right? Not okay, okay, don't worry. First of all you calculate, then you go with calculations of body wave velocity. Calculations of body wave velocity. So let us consider a wavefront. First of all, we consider a wavefront, right? Okay, this is a wavefront, and we consider that is the point, the source of seismic wave. Okay, so here the seismic waves are propagated. Okay, okay, yeah. So we consider this is the seismic ray. Seismic ray. Okay, and in this wavefront we consider coordinate systems also. This is the x-axis, this is the y-axis, this is z-axis. Okay, first of all we consider a wavefront. So we consider a wavefront, and in a wavefront defined the Cartesian reference system. Okay, so we consider a wavefront and defined Cartesian reference axes. Cartesian reference axes. Here x-axis, here x-axis is parallel to the direction of directions of propagations of the plane wave. Yeah, directions of plane waves, exactly. And the y-axis and the z-axis lie in the plane of the wavefront. Okay, the y and this z axis lie in the plane of the wavefront. Okay, this is the actually first representations. Now in the x directions, actually what happened in the x directions? In the x directions is parallel to the directions of propagations of plane waves. It means in the x directions particle have a motions. So h in the x directions plane wave propagates hence in the x directions the particle motions particles have a motions like back and forth, because particle execute simple harmonic motions. Back and forward. Okay, in the x directions or parallel to the propagations. So due to this, so this results in the medium what happened? Medium alternatively stretched and condensed in the directions of plane wave directions, right? So in the x directions particles have a back and forth motions, and the medium have sometimes have a stretched, sometimes condensed, right? So this result in the medium being alternately stretched and condensed. In these directions, okay, in these directions, okay. So this is the principle. So hence when body wave transmitted, so it means when body waves transmitted, okay, as a sequence of rarefaction and condensation. Important, body wave transmitted through a medium as a sequence of rarefaction and condensations parallel to the x-axis, okay. So this is the very simple problems we deal with one by one, right? So this is the result. So like that, rarefactions and condensation, this is the two case arise here. The two case arise here actually. Okay, when a body wave propagate through mediums. Okay, now let us consider the area of this wave front, जो wave front actually propagate कर रहा है. The area of this wave fronts, let deal with mathematics. Let ax in the x directions, area of the wave front, okay, area of the wave front, and also and fx is the force acting along the x-axis, Now, due to this force along the x-axis, there will be some displacement. So, due to this force, okay, and force wave produce a displacement. It produced a displacement u, okay, sorry, produced a displacement u. Okay, so now at the, let us take positions. Now let us understand it a proper way. This is the x direction. This is a certain point x, and we apply here a force fx, right? And this is another point x plus dx. These are the 2 points. After applying some force f of x, that point will be displaced at a point. So this is the displacement of this point is u, and also the displacement of that point x plus dx is u plus du due to this force along x directions, right? Okay, these are the two displacement. So u is the displacement of the particle at point x. Okay, let us understand one by one. U displacement of particle at point x, and u plus du displacement of particle at position x plus dx. Okay, due to force Fx plus dfx due to force Fx. Okay, these are the 2 points. Yeah. So finally we get due to this point, right? So hence so you just keep in mind, we take one by one point. So here, what is dx? Dx is the small length of a small volume element. Okay, so mass of this volume element is equals to rho dx ax. So we already calculate small volume element displaced, right? So now the net force acting on this element in the x direction. So now net force acting on this element in the x directions h fx plus dfx minus fx, that is equals to dfx, that is equals to del f upon del x into dx, the net force acting on this element. अब यहाँ पे क्वेश्चंस आएगा तुमको माइंड में, ये जो फोर्स एक्चुअली अराइज हो रहा है किसके वजह से अराइज हो रहा है, राइट? लेट अस टेक ए पॉइंट हियर, नोट प्लीज रिमेंबर दिस, द फोर्स Fx causes by the stress element along x directions. This is the normal component acting on the area Ax. This is a basic theory. Okay, right? So Fx is equals to, as we know, the stress, normal component of stress is equals to Fx upon x. So force acting due to stress is equals to sigma Ss on x. So this is equation 1, this is equation 2. Okay, now we allow, so this stress, this allow us to write out the one dimensional, now the one dimensional equation of motions for this small volume element. Now okay, so we consider a small mass element, and this mass element have a displacement u due to force F, and have a displacement u plus du for F plus dfx force, right? And this Fx force causes by stress, right? So these two force, this two force acting on this volume element is two force, right? So the one dimensional equation of motions now mention equation of motions is equals to force on mass element, that is equals to m ax dx into dtu upon dt square. This is the accelerations, that is equals to dx ax on dx. Actually change. So ax is cancel each other, dx each cancel each other. Okay, so we get del to u upon del t square equals to 1 by rho equals to x. This is equation number 3, right? We know that from the definitions of Young modulus, we have Young modulus A equals to stress by strain. Okay, so from these equations we get sigma stress equals to E into stress, and that is equals to del u upon del x. That is equation number 4. Substitute equation 4 in equation 3. We have delta u upon del t square equals to 1 by rho E upon rho del upon del x del u upon del x. So that is equals to del to u upon del t square E upon rho del to u upon del x square. Okay, so this is the equation number 5. So that from this equation number 5 we get the velocity of this wave. So this term is called velocity of the wave. So velocity of the wave v equals to root under E by rho. Is the elasticity, sorry, not Young modulus, rho is the density of the medium. Okay, we get this too. Now we know this is the general this is actually general relations. Okay, this is actually general relations. Now we calculate for body wave. As you know, the body wave passes through velocity of body wave. That is very important. Velocity of body waves, right? As we know, the body waves passes through a medium as a series of dilation, and compression. Okay, compressions. So there will be relations between elasticity. So young modulus. So now the velocity of body waves alpha is equals to lambda upon 2 mu upon rho, or alpha is equals to k upon 4 by 3 mu upon rho. One for dilation, another for compression, right? So these are the two expressions for body wave velocity. Okay, these two are the body wave velocity. Okay, and this body wave is actually, when propagating through a medium, the medium have a deformations along the propagations. So this type of is called, that's why the body wave is called longitudinal wave. So here take a note. H, body wave propagate through a medium then there have elastic deformations of medium along a particular directions, along one directions. So why body wave called longitudinal wave. Longitudinal wave, and this longitudinal wave is faster. 2 point, longitudinal waves is the faster of all seismic wave, of all seismic waves. That's why, hence it is called primary wave. Or P waves. Okay, so body wave is called longitudinal wave or P waves, and this P waves is the faster than all seismic wave. Okay, from the expressions 5, 6 and 7, from the equation 6 and 7, from equation 6 and 7, we confirm P waves can travel through solids, liquid, and gases. Okay. Point 4, for solid, p wave velocity for solid alpha equals to root under k plus 4 by 3 mu upon rho, because for solid k not equals to 0, mu not equals to, because solid have a shear. Why this is not equals to 0? Because solid have shear, but p wave velocity for liquid gases is alpha equals to k upon rho, because for liquid k not equals to 0 but u equals to 0. Why equals to 0? Liquid and gas do not allow shear, because liquid and gas do not allow shear. Okay, so for p wave velocity or body wave velocity, longitudinal wave velocity, these are the expressions. So today's class is actually based on body wave velocity and different case. Okay, in the next class I'll discuss transverse velocity or S wave velocity. Oh, okay. Okay, thank you for watching this video. Please subscribe and like my channel.